Welcome to my YouTube channel. Today we'll be discussing indices. We'll be solving some questions on indices. If you have been following this series, in our last video we were able to explain laws guiding indices, but in this video we'll just be applying those laws. If you have not seen the video, kindly check this YouTube channel. You will see the video on laws of indices. So let's quickly apply those laws in this video. As you can see on the screen, we have some questions. Simplify the following. So let's dive straight to solving the question. Question number 1. This is what we have here. As you can see, a raised to power 1 over 3 times 2a raised to power minus 1 over 2. That's what we have here. So let's dive straight into it. Now, we've been able to explain in our last class that if a base is carrying a negative power, it simply means it is 1 over, that is what it means, 1 over. So let's get the template for that and represent this with that. So this negative power simply means 1 over, that's it, 1 over, now a raised to power 1 over 3. That's what we have here. So this negative has gone. We've been able to iron out this, applying one of the law. Now this 2 is standing alone. We apply the same rule here. This a raised to power minus 1 over 2. This minus simply means 1 over, so let's get this as a template. Awesome. So this time around, it is not 3, it is 2, but we should not forget that there is still 2 here, multiplied by what we have here. Awesome. So we've been able to interpret what we have up here, down here. What we have here, this is it. This one that we have here, this is it, and these 2 that is standing here. So what we just need to do now is to multiply all the numerator, 1 times 2 times 1. That's what we need to do. So let's quickly do that. Let's get the template. Awesome. So multiplying all this numerator, 1 times 2 times 1, give us 2. This will give us 2. Now, what we have here is a raised to power 1 over 3 times a raised to power 1 over 2 beautiful. So with this, now we are now going to apply another rule from our law of indices. Let's see what we can apply again. Now if you are having the same base, look here, we have the same base, a, different power, but multiplication is in between them. We are going to add the power. Just take one base and add the power. That's what one of our rules says. Take the same base and add the power. Since they are having the same base, a, we've taken a. Let's add the power. 1 over 3 plus 1 over 2. Just add the power. That's what we've done. Awesome. So having done that, we are almost done. It's just to simplify. This is pure and simple LCM. What we have here. So we'll just work on the denominator now. Beautiful. So what we'll do now is to do what? Simple LCM. Now, what is the LCM of 3 and 2 that we have here? It is 6. Awesome. How many times will 3 go in 6? That's 2 times 1 give us 2 plus, because we are adding and it's a fraction. Whenever you're adding a fraction, you use LCM in most cases. Now, how many times will 2 go in 6? 3 times 1, 3. Awesome. So what we just need to do here is to work on what we have here. 2 plus 3 up here will give us 5. Beautiful. So we now have 2 over a raised to the power 5 over 6. We can leave our answer like this, or you can still apply the same principle. If you say you have a raised to the power 5 over 6, can still come up to be a raised to the power minus 5 over 6. You are still saying the same thing. So depending on what you actually want and anyhow you want to put it, it's just for you to come and put a negative sign here. Beautiful. So if you leave your answer like this, you are correct, and if you leave it like this, 2a raised to the power minus 5 over 6, you are still correct. So let's dive straight to question number 2. Awesome. Now, this question number 2 says 32 over 243 raised to all raised to power 5 over 6. You need to take note of that. Now, what this simply means is that this 32 raised to power 5 over 6 and this 243 also raised to power 5 over 6. So you need to take note of that. So let's get this as a template. Let's get this as a template. Awesome. So now say we have 32 here raised to power 5, 6 over 5 this time around, 6 over 5. So let's make use of this we have here. Beautiful. So we'll just try and see how we can edit this. We have 32 raised to power, this time around 6 over 5 up there, because this power actually belongs to both the numerator and the denominator. So at the same time, we have 243 here, 243 raised to power 6 over 5. Beautiful. So this power belongs to both the numerator and the denominator. So what this simply means, we are going to be applying a law now, one of those laws. Now you have power of fraction. If you recollect, we'll say the denominator is actually the root. So now we now be having 5th root of 32 raised to power 6, and here we have 5th root of 243 raised to power 6. Now let's quickly do that. Let's get a template. First of all, we have this, then we'll now come here and get this symbol. Awesome. Awesome. Now with this, we can now say fifth root. If you still remember, the denominator of this fraction, which is the power, will be what will be outside. We've taken our time to explain in our law. You can check the video now. Now I have fifth root of 32 in here with a power. Beautiful. So let's put this also so that we can make good use of it. Awesome. Now for here we have 32. Beautiful. And here 32, and the power is now going to be what? To be 6, like we earlier pointed out. Now let me come again, because we have 32 raised to power 6 over 5. It's going to be what? Fifth root of 32 raised to power 6. Now at the denominator here is going to be fifth root of 243. Fifth root of 243 to the power of 6 as well. You can see we've been able to iron out and simplify this one after the other. Awesome. Having done that, what that means for us is we are going to be looking for number that we're going to multiply 5 times that will give us 32. Very easy. If you say 2, multiplying 2 in 5 places, it will give us 32. So let's go. 2 times 2, that is 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. So what this means is we are looking for a number that you multiply 5 times that will give us 32. In the same vein, you look for a number that you multiply 5 times that will give you 243. So what number are we multiplying 5 times that will give us 32? It's just 2. That's 2. Beautiful. So if you multiply 2 into 5 places, it will give us what? 32. So raised to power d6. So also here, what number are we going to multiply in 5 places that will give us 243? It is very simple. 3. Because if we say 3 times 3, it will give us 9. 9 times 3, it will give us 27. 27 times 3, it will give us 81. 81 times 3, it will give us 243. So here we will now say 3 raised to power 6, because it is 3, we will multiply 5 times, that will give us 243. So let's make use of this as a template. So it is 3. Beautiful. Having done that, our job is quite easy from there. So we are almost done. So with this, we can now say, okay, let's get a template. Beautiful. So if you say 2 raised to power 6, that is, you are multiplying 2 6 times. 2 times 2. You can leave your answer like this, or you can still put it in this form. You can just multiply it and see what you are going to get. 2 times 2 is 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, that's 64. So you have 64. Then for 3 raised to power 6, that means you are multiplying 3 into 6 places. 3 times 3, that's 9. 9 times 3, 27. 27 times 3, 81. 81 times 3, 243. 243 times 3 will give us 729. 729. Awesome. So you can leave your answer in any of these formats. So let's dive straight to question number 3. It's just applying basically all the laws we've been able to explain in our last class. So for question number 3, the same thing we are going to be doing. We are just going to be applying those rules, those laws. So when I say rule or I say law, I still mean the same thing. So it's just for us to do the needful. Now, it is very easy. It's just for us to say, okay, let's get out this. Awesome. 4x raised to power minus 2. Like we have said it over and over and over again, that this minus, if you bring it up, it is still the same thing as 1 over, but what we are going to do for this question is to iron it out one after the other. So let's go. Now, these are the numerator, this and this, and these are the denominator. So let's just bring this numerator together. 2x raised to power 6 times 1 will still give us what? 2x raised to power 6. Beautiful. That means we'll be able to bring all this together. Beautiful. So we'll be able to bring all these together. So what can we do again? It is very easy for us. Now, you can split this. You can say 2 goes here 1, 2 goes here 2. Or you can decide, because you have this x raised to power minus 2 here, if it comes up, the sign will change to plus. So depending on how you want to do it. So let's bring this out for record purpose. Beautiful. So depending on how you want it. So here we can say, let's get this as a template as well, so that we can say this 2 over 4 is still the same thing as what? 1 over 2. Awesome. So, and you can put your multiplication if you want. So you can put your multiplication sign here. It is still the same, depending on what you want. Now, this and this has gone to this side. Beautiful. So we are left with this. Beautiful. So now we are having the same base. This is s raised to power 3 divided by s raised to power minus 2. Okay, don't get confused. This s raised to power 6, it is still the same thing as s raised to power 6 divided by s raised to power. Okay, let me put it out here so that you will not get yourself confused. Let me bring it out, because it is still the same. Divided by, it's just for us still applying our laws. Beautiful. So it is still the same, saying s raised to power 6 divided by s raised to power minus 2. This is s raised to power 6 divided by s raised to power what? Minus 2. So anyhow you want to put it, you are still correct. So now apply one of our laws. If you have the same base, different power, and you are dealing with division in between them. All you just need to do is to take the base and add and subtract the power. Sorry, if it is multiplication, you will add the power. Now it is division, you subtract the power. Now let's take the same base now. Because they are the same base, we just take one. Now let's subtract the power. 6 minus, don't forget to now have a minus there before. 6 minus 2. So now you just take the same base x, you subtract the power because we have divide here. 6 minus, we have minus 2 here before, so awesome. So with this, minus times minus here will give us plus. So this will leave us with plus. Beautiful. Having done that, so we see 6 plus 2 here will give us what? 8. Awesome. So with this, we just have our job easier now. It's just to say 1 over 2 multiplied by s raised to power 8. Just remove what you have there. You can leave it like that, or you can just decide to remove this multiplication sign. And here you are, your final answer. Let's dive straight to the last question. Question number 4. Very easy. Very easy. Beautiful. So for the last one, applying the same principle with what you have here. This, it is just the same principle with what you have here, but this time around with different numbers. So let's just take what we have here. Let's just take this as a template to make our job easier. Let's take what we have here as a template to make our job easier and faster. As a template, so we are going to edit this just in the same fashion, in the same way. Beautiful. This is just a template we are just going to be editing. Now here we have 16 over 81 raised to power 3 over 4. The same thing. It means this 3 over 4 belongs to 16. 3 over 4 belongs to what? 81. So here we now have okay. Let's see what we have. So we just put our 16 here because it is the same method with that question. Let's just edit what we have there to make our job easier. 16 over 81. This time around is 3 over 4. Let's do away with this. So 16 raised to power 3 over 4 because it actually belongs to both of them. So 16 raised to power 3 over 4 beautiful. 81 raised to power 3 over 4. Awesome. 81. Beautiful. Now it's going to be 4th root this time around. 4th root of 16 raised to power 3. 4th root this time around of 16 raised to power 3. And this time around, this one will be what? 4th root of 81. Raised to power 3. Beautiful. So we're almost done. So what number are we going to multiply 4 times that will give us 16? That's 2. 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. That's 2. So it's going to be 2 raised to power 3 here this time around. And what number are we going to multiply 4 times that will give us what? 81. That's 3. 3 times 3, 9, 9 times 3, 27, 27 times 3, 81. So it's going to be 3 raised to power 3. Beautiful. So you can leave your answer like this, or do it further. 2 raised to power 3, that's 2 times 2, 4, 4 times 2, 8. Beautiful. Then 3 times 3, 9, 9 times 3, 27. So we have come to the end of the video. You can always pause, rewind this video for better clarification and understanding. Don't forget, help us like this video and kindly help us subscribe to this YouTube channel, My Simple Maths. And don't forget to on the notification button so that you can always receive notification from us whenever we post a new video. Thank you.